Dear learners, welcome to 10 Minutes Lectures in Computer Science. In this lecture, let us learn about the way to avoid cascading rollback, which is possible under 2PL, two-phase locking concurrency control protocol. Before discuss the solution, let us recall what is concurrency control. It is the mechanism to handle transactions that are executing simultaneously, especially when one or more transactions trying to access same data item. The concurrency control protocols make sure that those conflicting transactions to execute in serial order in order to safeguard database from inconsistencies. What is cascading rollback? When one transaction is failed or decided to roll back for some reasons, in that case, the other concurrently executing dependent transactions also have to be rolled back. So here, dependent transactions are those transactions that have consumed the data item which was produced by the failed transaction. Because of this action, the concurrently executing dependent transactions have to be rolled back. Such a series of rollback is called cascading rollback. We discuss this with an example. Let us take the schedule with three transactions T1, T2 and T3. Also, let us assume that the value of data item A is equal to 1000 before transaction. So the T1 is going to read 1000 and it does something with the value and it writes a new value as 2000. Again, the transaction T2, which is waiting or which is happening next, is going to consume the value 2000, which is written by T1, and it produces a new value 3000, and so on, like T3 consumes 3000. Now, for some reason that T1 is decided to roll back, that means it has to roll back to the old consistent value of A. So whatever written by 2000 is not valid here, so it has to roll back that to 1000. That means that value read by T2 is also not valid one. Also the value which was produced by T2 is not a valid one. Also the value which is read by T3 is also not a valid one. And all these transactions, that is T2 as well as T3, have also to be rolled back. Why do we want to avoid cascading rollback? Because it causes several works to be undone. We need to undo all the works so far executed by the dependent transactions, and we need to start from the scratch again. It causes the wastage of CPU time. Two-phase locking protocol is a lock-based concurrency control mechanism used to handle concurrently executing transaction. It has two phases. One is growing phase, where the required number of locks acquired on the requested data items, and in the second phase, shrinking phase, where the locks are released one by one. And two-phase locking protocol, this version is also referred as simple two-phase locking protocol. Let us discuss with an example schedule consisting of transactions T1, T2 and T3. Here, when T1 requests for exclusive lock on data item A, the lock will be granted if the data item is free. Likewise, T1 requests for B, lock is granted. Then once all the locks acquired, because T1 it seems only A and B locks are required, then it can start with the transaction. And if it writes successfully the value of A, it can request for unlock. It releases a lock. So remember, it has some more instructions to be completed, but before that it releases a lock on A. Now what happens? T2 is waiting for lock on A, so it acquires a lock on A, and it does the same thing. It uses the data item that was produced by T1. Once it consumes the data, it writes a new value of A and it also releases a lock, and it happens continuously. T3 uses the lock on A and it continue with reading or whatever it is. In this case, if you see these two reads, T2, the read performed by T2, which is trying to read the value produced by T1, and the read by T3, which consumes the value produced by T2, both are called as dirty read because these two operations performed before the transaction which produced the old value not yet committed. T1 is not yet committed, but T2 consumed the value produced by T1. T2 not yet committed, but T3 consumed the value which is produced by T2, and so on it happens. Now if T1 decided to roll back, T2 and as well as T3 has to be rolled back because they have consumed the value which was produced by T1, which is no longer exists. Such a problem exists in case of the simple two-phase locking protocol. We just discussed the problem with the simple two-phase locking protocol. It releases the locks, exclusive locks held on a particular data item immediately once the data item is consumed. So even before the transaction commits. So this permits a dirty read by other transactions. This in turn may lead to cascading rollback. So in the next version, strict two-phase locking protocol, we are going to acquire the locks in growing phase, right? Like the same manner what we have discussed in simple two-phase locking protocol, but releasing the locks. We don't release the lock. It is exclusive locks are not released immediately. They are kept by the transaction until the transaction commits. Let us see an example. So same schedule I have taken. So T1 requests for lock on A, granted, lock on B, granted, and it uses the data. It produces a new value of A, and once it is done, the unlock will not happen at this point because A is locked using an exclusive lock, hence this unlock request cannot be executed. It has to be executed at the commit only. So it leads to the situation where the request by T2 on A cannot be granted. The lock request by T2 on A cannot be granted. So T2 cannot proceed further. Because of this case, T3 can also not proceed further. Now if a rollback happened, for example, T1 decided to roll back, only T1 will be rolled back. No need of rolling back of T2, T3. Of course, they have not yet started. Maybe they may not yet have started at this stage. So this way, we can avoid cascading rollback using strict two-phase locking protocol version. Thank you. In this video, we discussed about how do we avoid cascading rollback with a version of two-phase locking protocol. If you have any queries, you can visit exploredatabase.com. Thank you.